what we're going to do today is go over writing equations of lines that deal with comparing them to other lines using the words parallel and perpendicular. So we're going to be writing equations in both standard form and in slope-intercept form of lines that pass through certain ordered pairs and are either perpendicular to a given line or are parallel to a given line. So we're going to study the concepts of parallel and perpendicular and how they tie into linear functions. So the first thing I want to do is get into the notes about parallel and perpendicular and how they relate. Now in the textbook we have page 85, which has a graphic about parallel lines like this and perpendicular lines like that. So you have to remember what you can from parallel and perpendicular. And that's where I'm going to start building the notes. So it'll be helpful to remember about parallel lines. Now, parallel lines are those lines that, they never touch, but what does that have to do with slope? So we're going to study what parallel lines have to do with slope. Parallel lines have the same slope. Okay, so you're looking at two different lines that are never going to touch. Their slopes are the same. So when we look at this picture in the textbook, parallel lines, their slopes are the same. Remember what slope describes. It describes rise over run or how slanty a line is. They're the same slope. They will never touch. So that's an important note to keep in mind. Perpendicular lines, their slopes are called opposite reciprocal. Opposite reciprocal. Okay, so perpendicular lines have opposite reciprocal slopes. Now, an example of what an opposite reciprocal is. Okay, so we're going to talk about what is an opposite reciprocal. So let's say I had a slope of -2/3. Well, opposite means I'm going to change my sign to positive. Reciprocal means I'm going to flip it. So the opposite reciprocal of -2/3 is +3/2. Okay, and that's what the opposite reciprocal means. Okay, so opposite, change the sign. Reciprocal, flip it, or take the inverse. So perpendicular lines have slopes that are opposite reciprocals. Okay, so we go back to this picture. Whatever slope this line is, if this line is perpendicular to it, its slope will be the opposite reciprocal. And that's what all this stuff means. Good luck deciphering that. Or take these notes. Okay, so parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope. Everything else is old news. Okay, so everything else is the same as what we've done before. All right, so in this first question where I'm asking, write the equation of line in standard form that passes through -3/4 and is perpendicular to this equation. Okay, so remember there are two things we need to write an equation. We need a slope and a point. Now, if you read carefully, the point is totally given. That's the easy part, right? Passes through this point. Done. Point is taken care of. Our point in this case is clearly -3/4. The challenging part is the slope. What is the slope that we're going to use? The slope that we're going to use is whatever is perpendicular to this equation. So we have to do some critical thinking. What slope would be perpendicular to this equation? Aren't we going to need to find out the slope of this equation? So we're going to need to find the slope of 9x plus 3y equals -18. Okay, we're going to have to find out the slope from that. And we can do it from two different ways. Remember, we could solve this equation for y, put it into slope-intercept form, find the slope that way, or we could use slope using standard form and find it that way. All right, so this equation to me is already in standard form, right? It's already in standard form. And if we remember to find slope from standard form, the slope in standard form is the opposite of a over b. That's how to find slope from standard form. So in this particular case, opposite of a is 9, opposite of a is -9, b is 3, So the slope of this equation, the slope of the given equation, and remember, always simplify slope, the slope is going to be -3. There is my slope. Okay, so that's the slope of the given line. We've done all that just to find this. But is that the slope that we need to use for the equation? No, because remember, I'm saying that's going through this point and is perpendicular to this. So we have to find the slope that is perpendicular to -3. And remember what perpendicular means. Perpendicular means opposite reciprocal slope. So we're going to have to find the opposite reciprocal of -3. So if we're going to find the perpendicular slope, the first thing is the opposite. We know if the slope is negative, the perpendicular slope is going to be positive. That's the opposite. Now what about the reciprocal of -3? Remember, -3 as a fraction is 1. -3 over 1. So we have -3 over 1, and we're going to flip that. We're going to take the reciprocal of that. We're going to have 1/3. So the perpendicular slope is positive 1/3. If the original slope is -3, perpendicular slope, that symbol means perpendicular. Perpendicular slope is positive 1/3. All right, so we had to do some problem solving. So we know the slope perpendicular to this equation is 1/3. Guess what? We have our slope. We have the point that we're going to use. The point is -3, 4. Now we're set to go to write our equation. So let's write the equation. And just like the previous set of notes, you can write the equation either y equals mx plus b or use point slope form. I'm going to use y equals mx plus b. Okay, do we have a y? We have a y. It's 4. Do we have an m? We have an m. It's 1/3. Do we have an x? We have an x. It's -3. Do we have a b? No, we don't. That's what we need to find. Okay, so we're going to find out what b is because this is not our y-intercept. This is not our y-intercept. We have to find what the y-intercept is. So we crunch some numbers. -1/3 times 3 times -3. So 1/3 times -3 will give us -1. And then we have plus b. And then we're going to add 1 on both sides. So we add 1 on both sides. And we find out our b is equal to 5. Okay, so our y-intercept is 5. Our slope is 1/3. We can now write the equation. So our equation is going to be y equals 1/3 x plus 5. Now, are we done yet? Well, I don't know. Let's read the directions again. So the directions read, write the equation of a line in standard form. Whoa, in standard form. So our equation has to look like standard form, right? Remember standard form, ax plus by equals c. Is this equation in standard form? No, we are not done. So we have to make this equation look like standard form. And remember the 2 rules for standard form. No fractions, and a must be positive. All right, so we're going to handle no fractions first. Okay, so no fractions. We're going to clear the fraction. Here we have a fraction of 1/3. We can have fractions. We're going to clear it. We're going to multiply everything by the denominator. So we're going to multiply everything by 3. And when we multiply everything by 3, we have 3y equaling 1x, or just x, plus 15. And again, this is not quite yet in standard form, so we have to make this look like standard form. We're going to undo the x on both sides. And then we have -x plus 3y equaling 15. Now it looks like we have standard form, but the a is not positive. We have to make sure a is positive. So from here we can change all the signs. And then we'll find out that x minus 3y is equal to -15. And that is in standard form. So this is the equation of the line in standard form that is perpendicular to the original equation and passes through this given ordered pair. Okay, that's how perpendicular works. Well, what about the second question? The second question is asking, write the equation of a line in slope-intercept form that passes through another given point and is parallel to this equation. So, just like before, we need two things. We need a slope and we need a point. And again, in the given question, we're obviously given a point. We have our point. The point is 2, -7. The question is, what is our slope? Well, it's whatever is parallel to this equation. So we have to find the slope of this equation. So what we need to do is find the slope of the given equation. Now, what is the slope of this given equation? And if you can tell, this equation is already in slope-intercept form. A little tricky, because it doesn't look like there's a number in front of the x. There looks like there's a number under the x. We need to have a coefficient of x. Well, remember, what is the coefficient of this x? A little 1. So what is the slope going to be? The slope is going to be 1/2. So the slope of our given line is 1/2. Now what we need to do is figure out, well, what would be the parallel slope? What would be parallel to a slope of 1/2? We have to go back to our notes. Parallel lines have the same slope. So parallel to 1/2, parallel to a slope of 1/2 is also 1/2. Okay, so we're going to be using the same slope. So the slope we're going to use is 1/2. So we have a slope of 1/2. The point we're going to use, the ordered pair we're going to use, is 2, -7. All we have to do now is write the equation. Okay, so all we have to do now is write the equation. And again, we could use slope-intercept form, or we could use point-slope form. I like using y equals mx plus b. I find it easier. Where we have a y, yes, -7. We have an m, yes, it's 1/2. We have an x, yes, it's 2. Do we have a b? No, it's what we need to find. B is the y-intercept. This is not the y-intercept because the y-intercept is when x is 0. This isn't 0. This isn't the y-intercept. We've got to find out what the y-intercept is. So we're going to crunch some numbers. We have -7 equals 1/2 times 2 is 1 plus b. We're going to subtract 1 on both sides, and we find b to equal -8. And with that b of -8, we can then plug it back into slope-intercept form. And we'll have y equals mx plus b, plus -8, or just -8. So we have our equation, but before we're done, we have to read the question again, make sure we're done. The question reads, write the equation of the line in slope-intercept form that passes through there. So our answer has to look like it's in slope-intercept form. Take a look at where we're at. That is slope-intercept form. We are done. So it is in slope-intercept form. We are done. So it's important to read to make sure you know where you're going with things. So remember the key notes, okay? Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slope. Everything else is the same as what we've been doing, and that's how we are writing linear equations. So make sure we are versed in that, and that is it for this unit.